So, maybe by now, you're starting to get a little suspicious, right? Remember, natural log, right? It's actually shorthand. It's shorthand for log base E. Right? And E is this strange number, 2.7182 something, 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 okay? Has to do with exponential growth, okay? So therefore, if I think about the special case, okay, where, oops, my constant A, right, is not just any number, 1, 2, 3, 4, 5, but if it was actually equal to that base number, E, okay? So let A equal E. Therefore, the derivative of e to the x, right? Well, e is just a number, okay, and I'm raising it to this power. It would be equal to e to the x multiplied by log base e of e, okay? Now remember what logs mean. Logs mean, what power do I have to raise this to, this bottom number? What power do I have to raise it to get this number, the top number? Well, the power I need to raise it to is 1, right? So in fact, the derivative of the exponential function is itself. Okay, you differentiate this thing and it never changes. Okay? Okay? Now that means that when you think about what e to the x looks like, okay, that means that at any particular point its gradient is its y value. So for instance, okay, let's think about the y-intercept there. Okay, at x equals 0, what's the y-intercept? It's 1, right? That means that the gradient of e to the x at that position is 1. In fact, this line is x plus 1. And you can verify it's a tangent. I'll show you why in a second. Okay? Alright, so here's this important result, right? Now, how do we bring this together with all of the other rules that we know, like, say, chain rule, okay? What would be the derivative of, say, e to the, I don't know, 2x? Now, you gotta be careful, okay? Because you look at this line and you're like, well, I differentiate this e to the whatever, and it's just whatever. It doesn't change, okay? But be careful, right? This, from here to here, is a function of a function. So this is chain rule in here, okay? So what I'll do is, again, with chain rule, you're probably starting to get familiar with it. You don't always put the substitution in. Let this equal, u equal this, blah, blah, blah. But I'm going to do it to illustrate a point, okay? So, let's have y equals e to the 2x, okay? And I'm going to introduce a substitution so I can use chain rule on this. So I'm going to say let u equal e to the, sorry, no, I just want 2x, okay, 2x. So therefore, y equals e to the power of u. Straight substitution. Is that okay? So I've done my replacement. Now the next part of chain rule is the inside and the outside, right? So the derivative, du on dx is equal to 2, right? And the derivative dy on du, because that's what I replaced stuff with, is, now this thing, that doesn't change. Right? That's just e to the power of one of them, right? So that's just e to the u. Okay? So now, when you put your chain together, right, dy on dx is dy on du times du on dx, so that my du's just cancel out. Okay? I'm going to get e to the u times 2, which is 2e to the 2x. Okay? Does that make sense? So what you've got here, the derivative of e to the 2x. This 2 came down up front because it's the inside function. Okay? Just like if you differentiated sine 2x, okay, if you did your exercises on this, right? It's not just equal to cos 2x, right? Sine doesn't just turn into cos here. You've got an inside function. So this is really equal to 2 cos 2x. Okay? Alright. Let me do one more example, just for the sake of it, okay? Just to get your brains practicing the chain rule. Y equals e to the x squared. And it looks terrible because you're like, how many indexes does this have, right? It just goes on forever. What do I do with this? Well, I differentiate the inside, and then I'll differentiate the outside, okay? So dy and dx here is, well, the inside function is x squared, right? So its derivative is just 2x. Bring the power down, reduce the power by 1, and now differentiate the outside, which is e to the power of something. And e to the power of something doesn't change. Okay? So it'll be e to the x squared. Chain rule. Okay?